Okay, so we've got our nice model created that physically we're reasonably happy with. And now we actually need to make it do something because at the moment, what will happen is that the muscles will just sit there and you'll get no movement. And without any movement, you can't do tendon travel. So, if you have no movement, then the maths doesn't work and the whole thing falls apart. So we need to make it move. If we're going to make it move, there are a few things that are going to make our lives a bit simpler. The first is we want to fix the things that we don't want to move. One of the things we don't want to move in this case is the trunk. We might as well fix that and just move the femur. So the easiest way to fix the trunk is to create a fixed joint between the trunk and the world. And that's very easy to create because actually the markers we need for this have already been created in the model. The model always creates a world marker that doesn't move, and it will have created a center of mass marker for the trunk, and that if we attach those together, it doesn't matter where they are, nothing's going to move. So let's create that joint first. Create joint. Let's call it the trunk fixed joint, and it's between the world marker, which is fixed to the origin, and the trunk center of mass marker, and it's a fixed joint. We don't need to add anything else to it. So that will immobilize this part of the model. The next thing we need to do is we need to activate the muscles. And we do that by creating drivers, which is something I haven't mentioned before. We can create drivers individually by creating them here, or you can do it from the elements. But in fact, it's so common that you want to just activate muscles in sequence, particularly for testing models, that we actually have a function that automates this for you. So if you look under elements, you've got this thing called create testing drivers, and it will create a driver for each muscle, and these will activate in turn. So in this one, it will activate one muscle and then turn it off and then activate the other muscle. If you had 100 muscles, it would create 100 drivers that would all activate in turn. So it's actually really, really very handy. We do it by activating this. We get the dialog box up. This is read-only. It lets you have a look at what the model looks like. Once you get used to these, it's actually very, very handy. The model's written in XML. You can see the definition of all the bits. So it's very nice, and it lets you see what you've created so that you can check you're reasonably happy with it. So we've got muscles, straps, joints, and bodies at the moment in the model. And we're going to put in these markers. So the markers, the drivers have an activation time. We've only two. We might as well make that reasonably long. I'll call it a second. So we have a second where it'll activate one muscle, followed by a second where it'll activate the other muscle. And it's got an activation value. Now, because there's not much going on in this, and we actually want it to move fairly slowly, because we're doing tendon travel, and so what we want is a fairly steady movement over roughly a second, going from the starting point to the maximum range of movement. And so if we activate it to 1, it will do it far too quickly, and particularly because we've left the muscles as default, so their physiological cross-section area is a square meter, which is pretty huge. So let's drop this right down to quite a low value, and the suffix is just a naming convention. If we click on apply, it'll create those drivers. So if you now look at the model, we'll see at the bottom we've now got a couple of drivers, and they have they cycle through and provide an activation to the muscles, and they do it in the order we've asked them to do it, and that's all fine. So they don't have anything, they don't show up anything on the model, but we can see that they're there and they're created. So now's, whoops, don't need to rename it. Now's the moment of truth. We'll find out whether I've got the joint ranges in the right position. I might have done, I might not have done. It's a 50-50 thing. So we'll zoom back a bit so we can see what's going on. We need to switch to run mode because we're actually running a simulation, and this is the left-hand side. So let's see what happens. Right, okay, so it's extending far too far. So we need to we need to change the order of the directions. That's fair enough. Let's rewind. We can also do that a bit slower. At the moment, we're set at a stride of 400, so it only updates the display every 400 integration steps, and that actually gives us a sort of real time. But if we actually slow it down, we'll see this happening a little bit more slowly. Stop there because it's not actually particularly interesting. It also shows the issue if you go outside your joint range on one of the muscles, which is quite fun. So back to there. So let's edit the joint. So the info lets you see what the joint looks like, which is nice. It's quite handy, but we need to edit it. So we go to edit mode, edit joint, and here it is. So obviously, minus 20 to 135 is the wrong sign. So it actually needs to be minus 135 to plus 20. So we can change that and switch to run mode. And now it can only go back a small amount. You can see 1 second was perhaps longer than it needed to be. I might actually reduce the, and then it goes the other way. And it does it in a reasonable sort of way. We've got bouncy joint limits, which is what's causing the effect now. And also you can see one of the issues that we've got that we might want to change. So because of the position of our things, that we can see that actually the moment time is really very low at high ranges. And that's interesting. So we'll leave that in there because, of course, that might be a feature, although actually with this particular muscle, it's probably wrong and probably means we need to alter things. But anyway, so there's our model, which does mostly what we want. And we can get on with the next step, which is outputting the data that we need to do the final calculation. And that's trivial. If you look at the thing here, you'll see that you've got outputs that you can enable for everything. What we need to enable for this is an output for the hip joint, which, amongst other things, will give us the angle of the hip joint, and we need to output the two muscles because they will give us the length of the muscles, and that's the information that we actually need to calculate from. So we're all set up to do that. Make it run a little bit quicker than it did last time. The way outputs work is they produce a text file that's readable by something like Excel, so it's tab delimited, and it's saved using the name of the item, and it's put in the same directory that the model is in. And that's automatic. It's to save you typing. It will overwrite things with those names if they already exist, so you need to be a bit careful about that, but that's how it works. And that's it, really. We'll be able to calculate the outputs, and I'll show you how to do that in the next video.